you doing? It's MrDoTheMath, and today we're going to talk about 3 ways to prove triangles are congruent. All right, 3 ways to prove triangles are congruent. All right, so we're going to talk about a few postulates, right? So when we have congruent triangles, we have 3 ways that we're going to talk about today, and we're going to talk about a few proofs, or go through some proofs. The first way is by sides, right? And the acronym that we use is SSS. SSS means side, side, side. So it means that when the sides of a triangle are congruent to the other sides, to the sides of another triangle, then the triangles are congruent. Then the triangles are congruent, right? So we kind of talked about this on Thursday. So this is basically saying that these 2 sides are congruent, these 2 sides are congruent, and these 2 sides are congruent. And because all of these sides are congruent, then the triangles are congruent. Okay? This is called postulate SSS, right? So when we get to our proofs, you can just write down SSS. SSS means what again?
Side, side, side.
Right, side, 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 right? Side, side, side. It's congruent to side, side, side. Okay? That was easy enough, right? All right, the next one is triangles are congruent based on side, angle, side, right? So if you have a triangle, a side, and an included angle and another side. Included is a special word here. So, side, angle, side, right? This means that if a side, an included angle, and a side are congruent to a side, included angle, and a side, then the triangles are congruent. Alright? So, the word included means in between. Included means in between. So, you got this side, the angle that's in between the other set of congruent sides, right? So, you got this side, the angle that's in between these other set of sides that are congruent. Side, angle, side. So these acronyms, these letters represent an order of congruency. So that means one side is going to be congruent, a pair of angles is going to be congruent, and then a side is going to be congruent. But they're going to be in order. So it'll be side, angle, side. If the angle was here, this wouldn't be side, angle, side. Right? Does everybody understand that? It has to read just like it says. So it's side, angle, side. Okay? Everybody good so far? Alright. The next one is going to be based on the angle and an included side and another angle. Alright? So you have an angle, an included side, and another angle. Right? Included means in between. So it's an angle with a side in between another angle that are congruent. So that means if an angle, included side and another angle are congruent to an angle, an included side, and an angle, then the triangles are congruent. Okay? So, you got an angle, it included. Included means, again, what does included mean? In between. Right? Included. In between. Right? So an angle, an included side, and an angle are congruent to an angle, an included side, and an angle. Then those triangles are congruent. Okay? All right. So let us see. So if I was to write this out, let's look at a proof. Let's look at a proof. We're gonna do a proof. And today we're just gonna look at side angle side proofs. All right. So look at this. And then All right. So let's make a 2-column proof. Let's label this. H, J, G, K. H, J, G, K. Okay. So you have some given information here. The given information is going to be your tick marks. All right. So let's start our proof. I need somebody to give me a pair of some given information in this particular picture, this diagram. What's given? Yeah, Ty.
H is congruent to G.
H is congruent to G? Is that given? Did you see that? Yeah?
No.
Where?
Look, two.
Say it one more time. KH is congruent to KG. How do you know? Yeah, these marks. So you got KH is congruent to, yes, oh my gosh, K and KG. Alright, KH is congruent to KG. That's given. Alright, hold on. What's next?
HJ is congruent to J.
HJ is congruent to JG. That is also given. It's given because of your tick marks. Okay? What's next?
KJ bisects HG.
We can't say KJ bisects because it didn't tell us that. But we can say something about KJ. We can say something about KJ. What about it? What do you think? What's up?
Oh, that KJ
It-
is congruent to KJ.
yeah, KJ is congruent to KJ. Why?
Because KJ
What's that property? Very good. Reflexive property. Does everybody see that?
Yeah.
Now, one thing I didn't say is that in order for triangles to be congruent, you need at least 3 congruent parts between the two. And so if we look at this, we have this is congruent, that's one side. We have this is congruent, that's another side, and then we have the middle is congruent. So we got enough to draw a conclusion. All right. As a result, Courtney, what can we say? Which triangle is congruent to what triangle? Triangle to what? HKJ is congruent to triangle.
Oh, GK.
There you go.
That's J.
GKJ. Good job. All right. And why is it congruent?
because they have to.
Say it, Blake. Exactly. Side, side, side. The sides are congruent. All right. That's it. There's your proof.
I like this.
You like it?
I don't.
You don't? It's easier than one we did before.
I
Dang. It's kind of mean.
didn't do homework because of that.
All right, so let's do another proof, and then we're gonna do this last part. Is gonna help us with our homework. All right, here we go. All right, now it's a lot like this one. So here we go. We got this triangle. Womp, womp, womp. A, B, C, D. All right, let's say in this particular example, it says given. They say AD is congruent to CD. That's given. Right? They also say that B is the midpoint. Somebody talked about midpoint earlier. B is the midpoint to AC. That is also given. Okay? Now we got to draw the rest of the conclusions. Alright, so the first thing they said is AD and CD are congruent. So when you're working these problems out in your notes, it's always cool, Mr. Gurman, is to mark out what they told us. So they said AD is congruent. So we can put a mark to represent AD and CD being congruent. That's the first part. Okay? Then they said B is the midpoint.
AB and BC is congruent too. Are congruent?
Huh?
Wait. Isn't AB congruent to BC?
Why?
Because B the midpoint.
Yes, there you go. Very good. Alright, so AB, that's the next part. AB is congruent to BC. Alright? Somebody got their proof paper out? Or somebody want to say why? Kiara just said it kinda. Yeah. So midpoint creates, right? Two congruent segments. Right? So that's the definition of a midpoint. Alright? So now we got these two being congruent. So we got two congruent parts. We need a third one. What would we have?
DB is congruent to DB.
DB is congruent to BD, or the same thing, right? Quoi? Huh?
SS.
Right. Reflexive. Bless you. Alright? Yes, Diggy.
You say that ADB is congruent to CDB.
ADB is congruent to what?
CDB.
Yes. Why?
SS.
Very good. There you go. There's your SSS proof.
This is easy.
Fantastic. Alright? So, let's look at, so now we've looked at some proofs. Alright? Now, we have another example. One more thing. Alright? So, we know more about side than anything else, but we're going to talk a little bit about SAS real quick. Alright, so, if you got, this is an example. This is what we got to look at. This is BAC, and we got EFD, right? In the example, they give us these marks, right? If we wanted to prove that these triangles were congruent based on SSS, what needs to happen? What needs to happen to make those both congruent based on side? They only said, this is all they gave us. What else do we need? What other information? Yes, Molly?
Bisected or midpoint.
Really? Okay.
Wait, are we talking about the two triangles or like
These two triangles. In order for these two triangles to be congruent based on this
we
rule.
need another equal?
Alright, what would that equal segment be?
I don't know.
Alright, help us out, Casey. AC is going to be congruent to who?
DF.
DF. That's what you need. Alright? So there's an example like this in our homework. So that the question is, what's needed to prove that they're congruent based on SSS? Okay? What would be needed to prove that they're congruent based on SAS? Side, angle side. What would be needed? Yes, Blake.
Angle D is congruent to angle E.
Very good. Angle B is congruent to angle E. As a result, these triangles will be congruent based on side, included angle, side. So you have to look for the included angle here. How do you feel? You good with that? Let's make sure I've covered everything. Yes? Somebody raise their hand? Alright, let's try one more example. I think we're good. Oh yeah, let's try one more example. Alright, so let's do one like this. Alright, Alright, so I said, what if I put an angle here? Alright, what would I need to prove these triangles are congruent based on side, angle, side? What would you need? Yes, Molly.
Would it be BC and EF?
Alright, she said BC and EF. Would that work?
No.
Not quite, because we don't have any SSA triangles. Yes, ma'am.
Wouldn't it be AC is congruent to DF?
There you go. AC, included angle. The angle not even in the middle. The angle has to be in the middle. So AC is congruent to DF. Right. Good. Alright. And what about for angle side angle? What would you need?
BC, I don't know. B, A.
Very good. Angle B is congruent to angle E. Good. How do we feel about this? So tomorrow we're going to talk about, we're going to look at some angle side angle proofs and some side angle side proofs. Okay? Alright. Don't forget to like and subscribe. And if you got any questions, comment below. Mr. Do the Math out.